Greetings. My name is Brad Toll. I am currently working as a PhD student in computer engineering at the University of Nevada, Reno. I would like you to show or demonstrate the results from a control run I did on the Segway Robotic Mobile Platform, or RMP. This control experiment is based on my research that is attempting to incorporate auction mechanisms into behavior-based robotic paradigm. This robot is using a Willow Garage's ROS and has mapping along with real-time constraints. However, in this experiment, we will not be using the real-time constraint. The objective of the architecture, ABBRA, which stands for Auction Behavior-Based Robotic Architecture, is to allow the robot to make the most opportunistic decision while considering all possible constraints, such as spatial, temporal, and state constraints. Since this is a control, the robot is only using spatial constraints. Therefore, the robot will simply choose the closest goal and execute that goal first. The course is as follows. There are 3 goals, yellow, orange, and red. And all 3 of these goals, the robot knows the location of these. There is an unknown goal, the green object, that the robot must find with the blob tracker from the camera. Once the robot locates this object, it has to center itself on the object at a close distance. When all is said and done, the robot will follow a path on a map that looks something like this.
Once again, you can see the robot will start in the bottom right corner, go to the yellow goal first, then go back toward the orange goal, discover the green goal, and focus on that. Then finish the orange goal, and then finish the test by going to the red goal. This video recording will have 2 different perspectives. One's the first-person perspective with the map, as you see now, and the second perspective will be with the third-person view that is hovering around the robot. Now, as the robot goes down the hallway, you will see, it's hard to see, but behind the light is a yellow poster board on the ceiling. That is the yellow goal. You will also notice orange construction paper poster board farther down the hall. That is to hide the green exit sign so the robot does not get confused by the green exit sign thinking that's the blob. Also note on the first person perspective, the map on the left, the red dots you can see barely right now, you'll see them better later on, represent the laser scan coming from the SICK laser that's mounted on the Segway RMP. Now, for your sanity and to keep the movie kind of interesting, I'll just cut out some of the travel time, which is just the robot moving forward. As the robot nears the goal, you'll see that it stops almost directly under the red mark, and it has to stop within 25 centimeters of the goal. It's not incredibly precise, but you can see it stops pretty close to where it needs to be by the red dot in the ceiling. And then we'll turn around and begin going toward the orange goal. Remember to keep in mind that the robot does not know where the green goal is, so currently it is going toward the orange goal. When it rounds the corner, it will discover the green goal and focus on that. Once the robot has rounded the corner, it will see the green goal. Here you'll see interesting behavior where the robot will go towards the green goal and then move away from it. That's because the wall of void is keeping it a safe distance from the wall. One of these turns, the robot actually gets the green mark close enough to the center to complete the center on green goal. After this is finished, the robot will simply move past the green goal and continue on going toward the orange goal. Now that the green goal is finished, the only two remaining goals for the robot to do is orange and red. Since neither of these have a time constraint, the robot will simply go to the closest one, which is the orange goal, then proceed to the final red goal. Here we see the robot rounding the corner and will actually make it to the orange goal. Once again, you'll see the robot is fairly well lined up underneath the red mark, which is the exact location of the goal. The orange paper, by the way, the poster board is just there for a marker. With the orange goal complete, all that's left is for the robot to do is the red goal, which it proceeds directly to and then finishes the control run for the implementation of the auction behavior-based robotic architecture, or ABBRA. Once again, the robot arrives underneath the red goal, and you can see the red mark on the by the poster board, where detailing where the exact goal's location is. And it shows once again the robot's fairly precise even for such a large system. So this chart details the processes that won the auction and in what order over time. As you can see, goal 1, the yellow goal, won first and was completed. Goal 2 then began winning, and the robot began moving toward that. During the middle of this run, it discovered the green object, and therefore goal 4, center on green, ran and won the auction. The oscillation you see between goal 4 and goal 2 is because the blob tracker is not perfect, but this demonstrates the robustness of the auction behavior-based robotic architecture. After goal 4 is completed, the robot resumes moving toward goal 2, finishes that, then finishes goal 3.